Inside of Visual Studio, I have a simple project open. I've added Ninject to this project using NuGet. Ninject is a powerful open source dependency injector for .NET. If you've never worked with Ninject, don't worry. For now, we just want to use it to reinforce one specific point. If we look inside our home controller, you can see that I've modified the constructor to accept a parameter. Normally this would cause an error like we saw earlier, but since I've integrated Ninject, this will actually work out just fine. If you remember back to our custom controller factory example, we wrote code to handle controllers that contain parameters. Ninject accomplishes this in a better and more powerful way using a custom dependency resolver. When you install Ninject through NuGet, it will add this file to our startup folder called Ninject Web Common. And inside this class is a fair amount of code. None of this code really looks like what we've been talking about, so why do we care? Well, this is actually the code that sets a custom dependency resolver for our application. However, it's a bit buried beneath the surface. The configuration is actually done inside of the initialize function of this bootstrapper class. If we jump out to our web browser for a moment, we can confirm this. I have the Ninject source code open on GitHub, and if you hunt around a bit, you can find this class called Ninject MVC HTTP Application Plugin. If we carefully examine this class, we can see where it sets a custom dependency resolver. This start method is called by the initialize method that we looked at in our Ninject Web Common file. We can confirm this by also looking at the code for the bootstrapper class in another tab. The initialize method is getting all of the Ninject application plugins and calling the start method, which in the case of MVC will set the custom dependency resolver. If we head back to our solution, I've also added a line of code at the bottom of our Ninject common file. This is where we can bind interfaces to classes to tell Ninject which types to create for our constructor parameters. I added in the same logging class example that we looked at earlier using the Ninject methods. Now, one last thing I did was place some code in our global.asx file. I added an event handler for the pre-request handler execute method. Remember, this event fires right before our MVC handler's process request method and our controller factory. The two lines of code inside this method simply print out the name of the current controller factory and dependency resolver for the request to our Visual Studio output window. That way we can confirm what classes are actually at work. Let's go ahead and run this project, and it should open up in the browser without any issues. So everything seems to be working fine, and our controller with the parameters didn't seem to have any issues. But let's jump back to our project to confirm what just happened here. Inside our output window, you can see where it printed out the name of the default controller factory and the Ninject dependency resolver. So you can see how Ninject has empowered the default controller factory to be able to handle controllers with parameters just by substituting the dependency resolver that it uses. Ninject is a great dependency injection solution, and it provides some really powerful features. However, it's just one of many frameworks that you could use in this scenario. The important takeaway here for us is that you can influence the capabilities and behavior of the controller factory by changing the dependency resolver that it relies on to create controllers.